Alrighty, in this video we're going to learn about algebra with inverses, and in particular inverses give us some very good tools for solving equations. Now if we're used to solving equations with real numbers, we might be solving something like this. We'd start by taking 1 from both sides and we'd end up with 3x equals 6. And then what we'd be doing there is dividing by 3 on both sides. So we'd end up having x equals 2 at the end of things. Now if we put this into matrix form, we're allowed to add and take matrices, that's all good. But we're not really allowed to divide matrices, so what would that step actually look like? Well, it comes down to inverses. So we know that the inverse of 3 is a third, and that's because if I do 3 times a third, I get 1, and if I do a third times 3, I also get 1. So rather than doing this step of dividing by 3, we're going to instead do this step. So we had 3x equals 6. I'm going to times by a third on each side. And that'll basically do the same thing. So a third times 3 gives you 1, so you're just left with x, and then a third of 6 is 2. So that's an equivalent method, we just never use this pesky divide symbol. So we're going to do pretty much the same thing here when we're solving matrix equations. So we've got this situation where ax equals b, and we're going to try and solve that first with algebra. So what I need to do is I need to times by a inverse on both sides. So I'm going to do a inverse on the left, and I'm going to do a inverse on the left over here. If you're left multiplying on one side, you have to do it on both sides. It's really important. And it is really important that we left multiply because now those are paired up. If we did it on the right, we'd get a inverse over here, which wouldn't pair up with a. So that gives you ix equals a inverse b. And we know that I sort of acts like 1, so that's just x equals a inverse times b. So realistically, what you want to do is you want to write ax equals b. And then you'd love to write x equals b over a. But there's no such thing as dividing by a, so the equivalent has to be timesing by the inverse of a. Kind of like how we times by a third before. Anyway, now that we know that, we can just work all this out. So first step, we'll work out a inverse, and that's going to be 1 over the determinant of a. Sorry, that needs to be a 3, not a 6, my bad. 2 times 3, take 1 times 5. And then we're going to swap those numbers 3, 2 and negate the numbers -1, -5, just like that. The determinant actually ends up being 1, so this ends up being a really nice inverse. It literally just ends up being 3, -1, -5, and 2. That is our inverse of a there. Now, let's work out what our x is. So it's supposed to be a inverse times b, and it will be. So it's going to be a inverse, which is 3, -1, -5, and 2, times our B matrix, which was 5, 1, -2, 3. And let's just work that out. So we're going to pair the first row with the first column. So you get 3 times 5, it's 15, plus another 2, so you get 17. You get 3 times 1, which is 3, take 3, you get 0. You're going to get -25 and take away another 4, so -29. And then you're going to get -5 plus 6, which is 1, just like that. That's what I'm claiming is my X matrix. So let's just check. I'm going to set up my matrices. So I've got A set up here, which should be 2, 1, 5, 3. We'll just pop that in. And I should have B set up to be our B matrix, 5, 1, -2, 3. Now, the way that you can check this pretty easily is just by working out the matrices. So shift matrix alpha A, we're going to do inverse. So A inverse times shift matrix alpha b should give us this matrix we found, which it does. But in theory, what I should be able to do is do a times x, and it should give me b. So let's check if that works. So I'm going to put this x matrix in, but I'll just put it in the C spot. So that matrix is going to be 17, 0, -29, and 1, just like that. And I should have the shift matrix alpha A times shift matrix alpha C, which is our X matrix, should give me B, 5, 1, -2, 3, which it indeed does. So we know we're right here. You can get more complicated matrix equations like this one here. So we started off with AXB equals C, and we want it on its own. So essentially, let's try and do our same method by timesing by A inverse on the left for both. So those are going to cancel out and give me I. So I'm left with x times b equals A inverse C. And now I want to get rid of the b. So I right multiply by b inverse. Very important that it's on the right. So what I've actually got is that x equals a inverse c b inverse. And if you had those matrices, you could then work that out.